Hi, this is Chris, and we are taking a look at questions 25 through 27 here in section 4 of SAT Practice Test 2. So for 25, it says the graph of the linear function f has intercepts at a, 0, and 0b in the xy plane. If a plus b equals 0 and a is not equal to b, which of the following is true about the slope of the graph of f? Okay, so for a plus b to be 0, what they're describing here is basically two values that are going to have the same number with opposite signs. So something like maybe a is positive 2 and b is negative 2, or it could even be the other way around. Maybe a is negative 2 and b is positive 2. But that's the type of value that we'd be looking at that would sum to 0. So let's see what that would look like as a graph, because they just want to know what's true about the slope. So let's see what kind of slope we get if we try those points. So if a is 2 and b is negative 2, so that means that the 2 points that they describe, that would be 2, 0, and then 0, 2. Let's try that one out. So, or I'm sorry, 0, negative 2. Hello. There we go. So 2, 0 would be here, and then 0, negative 2 would be here. And if we connect those and draw a line and try to figure out, I could do better than that. Let's try another line. There we go. Okay, so if we draw that line, let's see what's true about that slope. Is it positive? Yes. Is it negative? No. Is it 0? No. Is it undefined? No. Okay. Well, then we're left with answer choice A. That seems pretty easy, but let's just make sure that we actually didn't luck out or do something wrong. So we're going to double check, and let's just try it. What if we switched around those values? Let's see if it would change up our graph. So if we had negative 2, 0, and then 0, positive 2, let's see if we would still get a positive slope for that one as well. So here, negative 2, 0 would be here on our x-axis, and then 0, 2 would be here on our y. And if we connect those 2 points, let's see. Yep, it's still a positive slope, so we're in good shape. We didn't do something incorrectly or make a mistake or just happen to get lucky. It is a positive slope no matter what values we pick for that, and we can confidently pick A and move on to 26. And here we have another question dealing with a graph. It says the complete graph of the function f is shown in the xy plane above. Which of the following are equal to 1? So when you're asking when a function is equal to 1, it's always imperative to know that that's our y value. They want to know, where is y equal to 1? So if we look, we can see that it's equal to 1 here at this point on the left, and then it's also equal to 1 basically anywhere along this stretch. Anywhere between 1 and 3 for our x value, we'll get a y value equal to 1 along that portion of the graph. Okay, so let's take a look at our Roman numerals here. So when we see Roman numeral 1 and it says f of negative 4, just keep in mind that each of these values, that's your x value, and we want to know if y is equal to 1 at that particular x value. Well, let's find negative 4. So negative 1, negative 2, negative 3, negative 4. So at an x of negative 4, is y equal to 1? Yep, it is right there. So we can say yes to Roman numeral 1. And for these Roman numeral questions, it's a good habit each time you make a decision about a Roman numeral to go ahead and mark off your answer choices accordingly. So here, if we say yes to 1, we can already eliminate A and C, which basically means that even if we aren't able to figure anything out from Roman numeral 2 or 3, then we could still have a 50-50 shot of getting this right. But let's see if we can figure out a decision for Roman numeral 2 or 3. So here, for 2, f of 3 halves. And for a lot of people, it's easier to put that into decimal form. This is 1.5 as a mixed number, or 1.5 as a decimal. And when our x value is 1.5, so that would be on our graph. We'll zoom in a little bit, but that would be about here for 1.5. And if we check the y value, yep, it does look like at 1.5 we have a 1 there as well, which means we can say yes to Roman numeral 2. And hey, look at that. That allows us to eliminate B. We can already select our answer choice without even worrying about Roman numeral 3. But just to double check and prove it, here when x is 3 for Roman numeral 3, if we look on our graph at 3, we still have a y value of 1 there. So all three of these Roman numerals are true as to value of the function equal to 1 at those different points. Up next, we'll take a look at question 27. And here they show us this figure, and in the figure they have insulated and non-insulated. Let's see what they describe in the question. So here it says 2 samples of water of equal mass are heated to 60 degrees Celsius. One sample is poured into an insulated container, and the other sample is poured into a non-insulated container. The samples are then left for 70 minutes to cool in a room having a temperature of 25 degrees. The graph above shows the temperature of each sample at 10-minute intervals. Which of the following statements correctly compares the average rates at which the temperatures of the 2 samples change? So basically what they're describing here is that you have something that's starting out at 60 degrees for both of them, and then, as we might guess, an insulated container, right? So if you're thinking, like about a container that you have some water in, so maybe it's coffee or something like that, right? If it's insulated, it's not going to cool off as fast, right? So that's this insulated one looks like that, and then the non-insulated, it cools off a lot faster, right? So it has just a steeper drop to get to that room temperature. So that's what they're showing with these points along this graph. They're just comparing how quickly it cools for the insulated versus non-insulated container. Now let's take a look at our answer choices, and we're talking about the average rates at which the 2 samples change. So I'm going to zoom out a little bit so we can see the graph while we read through these. But for A, it says in every 10-minute interval, the magnitude of the rate of change of temperature of the insulated sample is greater than that of the non-insulated. And so here the insulated one, as we just said, that one changes less than the non-insulated one. So A sounds like it's the opposite of what we're trying to find. For B, it says in every 10-minute interval, the magnitude of the rate of change of the temperature of the non-insulated sample is greater than that of the insulated sample. And that seems pretty accurate at the beginning, right? We have much bigger drop-offs here for the non-insulated versus the insulated. But it does say at every 10-minute interval. And so if I look, I see that a little bit later on, what happens with that non-insulated one? And again, let's come back up here to the graph, but we can see that it drops off really quickly. But then once it gets to 25 degrees, remember the room temperature in this question is 25 degrees, so we see that it basically levels off here to where you have no change. These last few points for the non-insulated, there's no change at all, while for the last few insulated ones, because it's not yet all the way down to that room temperature, that's still changing. That's still decreasing. So we can't say that the non-insulated has a faster decrease or a greater magnitude of change than insulated for every 10-minute interval. For some of them, but not for every 10-minute interval. All right, let's check out C and D. So in the intervals from 0 to 10 and from 10 to 20, the rates of change of the temperature of the insulated are of greater magnitude. Nope, we can already eliminate that because, as we said, early on, the insulated is not greater. The non-insulated has a greater magnitude of change. And that leaves us with answer choice D. And let's just take a look at how that applies to the graph. But basically what they're saying here is that non-insulated have greater magnitude in those early time intervals. And that's what we see here. The magnitude, the change, non-insulated, you can see has much faster drop-off in those first couple of time intervals there than the insulated does. And then for the latter part of answer choice D, the intervals from 40 to 50 and 50 to 60, the rates of change of temperature of insulated are greater. And that's what we talked about in here. These last couple of intervals, we see basically no change for the non-insulated. And so that's where we get a